Hi everyone. Thanks for coming to my talk on Azure and Azure Service Bus. So before I start, some quick housekeeping. So we've got a code of conduct. There's a lot of words here, but it basically boils down to be a nice person. If you've got any issues about the code of conduct or any issues, then there's a URL there to report them to. This year they're supporting a charity, National Museum of Computing. So if you want to contribute to that, then there's a URL here. And thanks to the sponsors. It's always similar sponsors, and they make these events possible. So thanks to them. And if you want to tweet or publicize your experiences, then there's a hashtag DDD 2020. I'm guessing everyone's seen these slides a couple of times already. Okay, so on with the talk. This is me. You can contact me on Twitter, on LinkedIn. I've written a book on C#8, .NET Core 3, which so shortly after the time it was originally published is nearing the end of its life, I suppose. And I organise a meetup group called Mini Hack, which it would be great to see some people coming to. Okay, so demos. I'm going to do some live demos. Obviously, live demos are a bad idea, so I shouldn't be doing them. Stuff frequently goes wrong, so I'd appreciate if everyone just pretended that everything worked fine, whether it does or it doesn't, and we'll move on and never speak of it again. Okay, so I'm going to talk about Azure Service Bus. I want to emphasize that it's just a tool Microsoft have produced, and I'm not trying to sort of sell this as the answer to any number of architectural problems. You can use it for lots and lots of different things. You might decide to use it as a sort of event sourcing system, or for PubSub, or as an email scheduler. You probably use it for all of those things and many other things. So what I'm covering here is just some things that you potentially could use it for, not things that you definitely should use it for. It's obviously depends on your particular use case. I'm going to try and start from the basics, and I'm going to try and cover some of the cool sort of advanced features, but obviously I'm going to miss some stuff out because it's under an hour. Okay, so I thought we'd start by talking about what a modern system looks like. This is the sort of thing that you come into a new company, you've started as a developer, and they start showing you around the architecture. Might be service orientated. They might have some microservices in there. They're very likely to have a couple of APIs. Very likely to have a web front end. They may have some desktop apps. They may have some mobile apps. But the specific case that we're talking about is this box cylinder architecture, which you may find in all of those sort of buzzwords above. But you know, it's this situation where you've got I don't know, front end or API talks to some kind of database facade, and then there's data stored behind that. Okay, so what's wrong with that? Why are we trying to solve this problem? What's the problem we're trying to solve? Essentially, there's sort of two. The first one is the communication between services, and the second one is system load. So in communication between services, there's two types of coupling that tend to happen. There's logical coupling and there's temporal coupling. I'll talk about what both of them are shortly. And the system load can cause poor user experience from a slow system, depending on how slow, sometimes very poor user experience. Okay, so let's drill into what logical coupling is. So I've got two services here. You can transpose the term service for process or whatever. So this might be a website, and this might be an API. They might both be APIs. It doesn't really matter. But service one calls service two. The problem is that service one needs to know what service two is. It needs to know where it is, and it also needs to know what it does. So, in this case, it accepts customer details, for example, and returns an acknowledgement. So let's see that in an example. So I've got a CRM backend here and a customer service. So we call the customer service, call create customer. Create customer accepts some JSON, passes back an acknowledgement. Everything's good with the world. However, if something changes in the customer service, then we've got a problem. So the customer service may now not return what's expected, or it may behave differently, or it may even crash. And the problem there is that there's a dependency, there's a coupling, and therefore the client in that sort of scenario can break. Moving on to temporal coupling. This is a different situation. It's more often seen with sort of RPC scenarios, but again, two services, same principle applies. Service one calls service two, and service two calls a method, and then service one calls service two again, and a second method's executed. So the problem here is that service one in this case must know what sequence the methods need to be executed in service two. And this is more common than you may think. It might not be as obvious as the example I'm going to give in a minute, but you might find that you call a method, and then through some business reason or whatever, maybe it's not as stark as the reason I'm going to give, but for some business reason, these methods do need to be called in order. So here, for example, I'm going to illustrate this with CRM backend again, the customer service, create a customer address, and then create the customer. So obviously, if the customer address doesn't exist, the create customer can't function. But like I say, it's not always as stark as that, but it is quite commonly present in successive API calls, even if it's only subtle. And system load. So I imagine everybody's seen this, especially if you've been shopping on Black Friday, which has just sort of come across. So service one's calling service two rapidly, and at some point service two can't cope with the load for whatever reason, and at that point service one can fail, or it can time out, or the customer just gets bored and goes away. And all of this kind of causes a poor user experience. So we've got here a user interface and a couple of services. So let's imagine a situation where there's some kind of poor internet connection between the two services. So we've got service one calling service two there. Service two takes a while for whatever reason, and then it responds. But the problem is the user might have got bored and gone to a competitor site, or it might time out. There's a number of reasons why this is a sort of bad experience for the user. So this is a talk on Azure Service Bus. So obviously the next slide is I'm going to say you need to solve this with Azure Service Bus. In fact, that's not really the case. I mean, what I'm going to say for the most part can be you can substitute Azure Service Bus for any number of other similar offerings. Most of them offer more or less the same functionality. I did want to talk about the fact that this isn't new as such. So one of the great things about being around in the industry so long is that you get to tell people what it was like 15, 20 years ago. And I wanted to give a couple of examples of situations where some of the functionality that's provided in event brokers, and we'll get onto that in a minute, was already sort of being leveraged back, before Azure was a thing. So EDI systems, I've worked on EDI systems in the past where, in order to stop the EDI system kind of being overloaded, we just wrote files to a disk, and then the EDI system picked them up as and when it was ready, in a similar manner to a queue. Email queues, similar sort of thing. So write a message to a database table, and then have a process. In fact, a process that if you looked at it in the right angle, you might call a microservice. Just picking them up and then sending out emails. And yeah, like I said, these processes tend to be Unix daemons. So you might have called them a microservice if you had the right marketing people in place. Okay, so I suppose the first question you should ask when you're saying we're going to use Azure Service Bus to solve a problem is, what is it? And the answer is, it's a message broker, which does sort of bring us on to another question, which is, what's a message broker? So it seems to be that a message broker follows these three tenets, if you like. So the first one is it needs to be a discrete service. So it's not a library, it's not a NuGet package. It's got to run in its own executable, its own process. Clients communicate with the message broker, not each other. I mean, that's kind of the point of it. So if that's not the case, then why bother? And broadly speaking, there's two types of communications inside a message broker, pub sub and queues. I can think of one message broker where that isn't the case, but broadly speaking, that's correct. Okay, so how do services communicate when we're using a message broker? Because we just said they can't talk to each other. In fact, what happens is a service will communicate with the message bus. So the message bus is this sort of bar at the bottom, and then the second service just picks up that message from the bus. So it might occur to you that we're creating a dependency here on a message bus, and you are. We have this with things like IOC. So with IOC, you create a dependency on an IOC container, and that's kind of it. You just kind of have to live with that. You can abstract it away a little bit, but you've got to depend on something. You've got to kind of you can't kind of get around the dependency completely. And yeah, you can abstract it away, like I've said. Okay, so the first tool or demo that I wanted to sort of give was Service Bus Explorer. So if you're using Service Bus, you'll sort of set it up on the Azure portal, and I won't go into setting up Service Bus as such. It's a relatively straightforward process. But if you want to have a look what's in Service Bus, then you need to use some form of tool that allows you to look at the messages. One such tool is the Service Bus Explorer, and that is at this very strange GitHub location. There's also a preview of it in the portal, but there's less functionality in that one, so we won't be using that one. We'll use the desktop one. Okay, so onto the first demo. So I'm just going to drag across this Service Bus Explorer. So what we can see here, I mean, this is a WinForms app that was written by a guy at Microsoft, as far as I can tell. We've got the queues here, we've got topics here. We won't be talking about any of the other stuff. And I'll speak more about queues and topics and subscriptions and so on. But there's a number of things that you can do with the Service Bus Explorer. You can look at messages in a queue or in a topic. You can clear the messages from a queue or a topic, so you can receive them, you can purge them, that's clearing them. And there's quite a few useful little functions that you can do. Okay, so first demo went without a hitch. So let's build on our success. Okay, so I suppose in delving into queues and topics, we'll start with queues. So what is a queue? So a queue, essentially, I've got a little PowerPoint illustration here. So essentially what happens is we've got a number of items in a queue, and what happens is the clients that are accessing that queue come and take items one at a time off the queue. It's broadly speaking first in, first out, although that isn't guaranteed. And the reason it's not guaranteed is for things like message locking and partitions and a number of things that I won't really be covering on here. But broadly speaking, it's first in, first out. A queue can have 0, 1 or more receivers. The 0 is quite important when we come to topics, but essentially, yeah, you can have a number of receivers for a queue, and you can scale out the queue by having as many as you want. Okay, so setting up a queue. So in order to set up a queue, I'm going to be doing, or this particular illustration that I'm going to have next is based on the Azure CLI. I'll talk in a minute about why the Azure CLI, but effectively the process is you create a resource group, as with everything in Azure, everything's kind of a resource group. Service Bus have a specific namespace they sort of live in. You then create your queue, and then the next step is to add a message to the queue. So I've got a little illustration here on setting up downloading and installing the Azure CLI. The reason that I wanted to use the Azure CLI is it's you can take a command that you've executed on the Azure CLI, you can put it in a script, and you can execute that script. You know, you can write a blog post on it. It's repeatable, whereas the Azure portal changes quite frequently. And so here is the default example. So AZ login, you type that, it takes you to the login page, you log in, and then you're good to go. Okay, so setting up a queue. So as I said, the first step is you create a resource group, and this is the Azure CLI command to create a resource group. I won't be typing these in at the minute, just because I've already got these things set up. But essentially, AZ is kind of your command, and you're reacting to a group. You need to give it a location. That's the -L. So in this case, it's UK West. You need to give it a name. In this case, it's Service Bus Test. To set up a queue, it's a similar sort of idea. So this time you're doing something on the service bus. You're creating a namespace, and then you need to give it a resource group. You might have noticed that there's two ways of referencing some of these. So if I go back, you know, -L for location, or you can do -- location. And there's sort of help docs if you have a look around for these things. And the same with creating a queue. So Service Bus queue create, give it a resource group, give it a namespace, and a name for the queue that you're creating. Okay, so queues. Let's have a quick demo of queues. Okay, so this is my demo app that I've set up. and we're going to be running this queue client demo. I'll go over the code in a minute, but first thing we're going to do is just run it up. Okay, so the first thing I'm going to do is I'm going to send some messages to the queue, and we'll be able to validate that I've sent some message to queue by having a look in Service Bus Explorer, and we can see that it's added 100 messages to the queue there. And the good thing about Service Bus Explorer is I can have a look what those messages are. So here you can see the messages, and I've just put GUID after it to make sure that you can kind of differentiate them. Okay, so the next thing I'm going to do is I'm going to receive just one of those. I'm going to receive just one of those messages. Okay, so that's number 3. Just receive a single message. Again, if I go back here, I can see that one message has been received, and I'll sort of go over how it's happened. And the second thing I can do is receive all of the messages. So this is on an event basis, so that's just going to go through and it's going to start receiving these messages. And if I come back here, I can see its progress as it's receiving these messages. Okay, so that looks like it's finished. So let's have a quick look at the code for that. Before I get into the code itself, I'll talk about the NuGet package. So there's one, these things are just for the sake of adding configuration, but there's one NuGet package that applies to all of this, which is Microsoft.Azure.Service Bus. And that's pretty much the NuGet package you need to interact with the service bus. Okay, so let's have a quick look in the program, and we can see send message code first. So there's nothing that should be hugely advanced here. We've got an object called queue client, which essentially establishes a client for the queue. You pass it a connection string, which you get from the Azure portal when you set this thing up. And that can be scoped based on the resource that you're using. And then all I'm doing is I'm just going around for like 100 times and basically forming a message and then calling this send async on the message. If we have a look at the direct receive, which just received one message, that was here, so that's a read message. So this sets up a message receiver, similar sort of syntax, and then just receives the first message on the list, and then yeah, just displays that. And finally, if we have a look at the event, so this is again a similar sort of idea, but this time we set up a queue, and this time we do this register message handler. And what that effectively does is it sets up an event that reacts whenever it receives a message, and then same process. So that executes for every message that's in the queue. Okay, so let's move on to the next slide. So topics. Topics are also known as pub sub. I think I'm right in saying that Microsoft are kind of the coiner of the phrase topic. I could be wrong about that. But pub sub, publish, subscribe. And essentially the idea is that you send out a message, and anyone who's kind of listening for that message gets a copy in their kind of personal queue. So you have multiple independent queues, and you can only see messages that you subscribe to. So unlike a queue, a message with no subscribers, much like a tree falling in a forest where no one's listening, is lost. So you broadcast a message to the topic and any subscriptions receive it. To set up a topic, similar sort of idea. So service bus topic create, you give it a resource bus, you give it a resource group, you give it a namespace, and then you tell it what it's going to be called. Okay, so let's see topics in action. Going to come back here and okay, just refreshing that. Okay, so we're going to go to the topic client demo. Again, all of the format of these projects are the same, just for the sake of ease of explanation. So I'm going to run this. Okay, so we're going to send some messages to a topic, and what we'll find here is quite interesting. So we've sent some messages to a topic, and if I do a refresh here, we'll see that actually nothing happens. In fact, this is the topic that we're sending it to, and there's nothing here. There's no subscriptions here, and so nothing's been received. So what we're going to do is we're going to add a subscription, and you can do that directly in the Service Bus Explorer. So we'll create a subscription, and we'll call it test subscription, because everything needs to be called test. And actually I've got some code that references this name, so it matters, the name. Okay, and what we'll do now is we'll run it again. And this time, if we come back, there's now 100 messages in that subscription, because we've now got something that's listening to it. So the next thing we're going to do, yep. So now we'll just show this sending and receiving. Okay, so I'll move that out of the way and bring this back and bring this back. So what we can now do is we can run a second version of this code. And while one of these is sending the message, we can have another one receiving it. So on here we'll receive some messages. That's receiving 100 messages. And as that works through, then what I'll do is, as soon as that finishes and it stopped receiving messages, I'll start sending them again. So that's now stopped, it's not sending anymore. I'll send these messages. We just had a question from Richard. So with a topic, all subscribers get the message. Yes, all subscribers get a message. However, you can set up rules regarding the subscription, which we'll cover later on. But yeah, anyone who's subscribed to the topic gets a message. Okay, so we've seen that that sends and receives, and we've seen the subscriptions. So let's go back to the slide deck. Okay, so we talked about queues and topics, which is great, but how does this actually solve our problem? How does it solve logical coupling, for example? So the services no longer need to know the location of other services, because they now know the location of the service bus, and that knows the location of the other services. Services will not now break directly because the data has been changed upstream. I'm coming to the caveats in a minute. Services aren't dependent on the health of upstream services, which is a similar sort of thing. So, you know, if you've got service 1 that's calling service 2 that's calling service 3 in a direct call situation. If service 3 broke, all of those would essentially go down, but that isn't the case now. And services no longer care what up and downstream services do. So if functionality changes, it's no longer the business of a service that even depends on what that service has done, because it's just listening for a message on a queue. And here's the caveats. So services are not, although they're no longer dependent on each other, they are now dependent on service bus. We've spoken about that a little bit. Although the services won't break directly because upstream services have changed, if they're expecting data that's changed in format, they can still break. But it's worth bearing in mind that that'll be an isolated thing. So you kind of still have to write your services resiliently. And although services might not care what up and downstream services do, we haven't removed the need to do those things. So. Okay, and how have we solved temporal coupling? So we do still have a dependency on a sequence of events. Ultimately, if you have a sequence of events that's a kind of business-driven set of rules, place the order, get the customer's address, dispatch the order, raise a credit note, whatever these things are, they have to happen in an order that's not like based on the technology, it's based on the real world. But separating tasks into logical blocks tends away from temporal coupling. So it encourages you to kind of make these things isolated. And although each event does need to occur in a sequence, that sequence is not necessarily known by any single process. So if you put a message on a queue saying next one, like you're the sales order service, and you put a message on the queue and you say, right, I've done my sales ordering, then the dispatch service can pick that up, but there's no single orchestrator of that says first sales order, second dispatch. And how have we solved system load? So each service now collects tasks as it's ready, so it doesn't get overloaded just because it can manage its own influx of tasks. The service bus basically acts as a shock absorber, so it accepts all of these things and kind of distributes them when it's ready. And you now got the situation where you can have multiple services dealing with the same queue, or even, I've put all topic, that's not strictly true, it's actually a topic subscription, but you can have multiple services that deal with the same queue of work, if you like, and there, so the load is then distributed. Okay, so user experience changes. So what we end up with, or what we can end up with, is a fire and forget system. So you place an order or whatever it is, and essentially what happens is you just put a message on on the bus, and that means that you can't really tell the user that their order has been anything's happened with their order. All you can tell them is that you've accepted it. That means response times are much faster because you're not really doing anything, you're just putting a message on a queue. But there is a question as to what if you need a response. And that brings us on to request response. So first of all, I wanted to talk about correlation IDs with relation to this. So again, I've got two services, processes, whatever they want to be, and in between them I've got a service bus. So process 1 calls service 1, or like I say, whichever way you want to do it, and it passes it a correlation ID. Service 1 replies, and basically what's happening here is process 1 is listening for the correlation ID that got sent. So when it sees that same correlation ID, it accepts it. and no others. Correlation ID is just a name for something that that matches the correlation between the two services. You shouldn't get too bogged down in the name correlation ID. You could use order number, so you could say process 1 sends across order number 123 to service 1, and then it's listening back for a confirmation with order number 123. So at this point, process 1 can either block and wait, so effectively behave in exactly the same way as your average sort of inline API call. Or you can change the UI completely. I'm no UI expert, but maybe this time you place an order, and then when the order is complete, the user gets an email, or they get a toast, like one of these little notifications at the top of the screen. Whichever way you want to kind of do that. Okay, so let's see how we can use correlation IDs using queues. So bring up my examples, and we're going to go to the bear with me while I refresh the service bus. These demos work a lot better when the service bus is empty, otherwise it just gets crowded with the relevant bits. Okay, so we're going to run service bus correlation ID demo. This one. Okay, so the first thing we're going to do is we're going to send the message, and then we're going to have a look at it in the queue. So the message has been sent to the queue, and we're going to have a look in the queue at correlation ID demo. And just a quick point about this. So I should have explained this before. So the receive mode, and this applies when you're using the SDK or whether you're using Explorer. Peek essentially allows you to look at messages without touching them, so you don't receive them, you don't move them from the queue, you just kind of look at them and then put them back as if, carefully put them back as if they've not been touched. Receive and delete basically gets rid of that message, so we're just going to peek. And as you can see, there's a message been sent to this queue, and the message is, what is the greatest band of all time? So hopefully during this demo we'll get an answer to that. I'm just going to move my notes here, and we'll move this back. Window. Okay, so now we're going to launch a second instance of that. There we go. Okay. So now what we're going to do is we're going to reply to that message, and it's asking me the correlation ID. I'll show you the code in a minute, but effectively I'm going to pass it this correlation ID, which is just a GUID. And as you can see, it's replied, and this has received the message. And as we can see, we've now found out the greatest band of all time. What I'm now going to do is I'm going to repeat that, but I'm going to send back the wrong correlation ID. So it's asked the question again, and here I'm going to reply to the message, but I'm just going to type in anything. And here it's saying, okay, I've received the reply, I can see it, but the correlation ID is different than I'm expecting. What is actually happening here is it's just having a look at these messages and not doing anything with the message if it's not the right correlation ID. So if I left this long enough, and I won't do because we haven't got time, it would keep receiving that message and keep rejecting it because the correlation ID is not changing. So we'll have a quick look at the code here. So we'll start with the send message. So all this is really doing You can pretty much ignore this task completion source. It's just a way of executing event-driven code as if it was procedural. If you're interested, I've written a blog on how you can do that, but it's not relevant for this demo. So all I'm doing is I'm sending a message, which we saw before, but this time I'm passing a correlation ID. So I did say the correlation ID, the name of the correlation ID doesn't matter. It doesn't, but if you use an Azure Service Bus, it gives you a free property called correlation ID, so you can use that. Or you can put the correlation ID in the message itself. It's up to you. And then the second thing I'm going to do is I'm reading a message, but I'm passing through this correlation ID that I want to read and sort of listen for. So what this is going to do is it's going to say, I'm going to register a message handler. I'm going to pass through some options. The options are set up here, and you notice here it says autocomplete is false. That means that as it's receiving the message, in the same way as we saw peek and receive and delete before, it's not going to actually get rid of that message. And then what I'm doing is I'm handling the message here. So if we go down to the message handler, as this receives the message, it's checking the correlation ID is what it's expecting. And then if it is, it writes the answer, they've received a matching reply and completes the message. And otherwise it just says, okay, I've not received the reply, and does nothing. Cool, okay. If there's any questions, just bungle them in the chat while I'm talking, and I'll get to them as it comes round. Okay, so queues are a good candidate for correlated messages in some cases. That tends to be longer running processes and scalable consumers. So, you know, if you've got if you're writing a spam engine to send out 1 million emails to 100,000 people that they you know, if you're a recruitment agent or whatever and you want to send out all these things to people, having this kind of scalable consumer is great, and it works great with queues. But if you want to use communication within a system, then you might want to have a look at topics instead. But then there is a question as to whether that works with topics. So here I've got a simple sort of example. So I've got a client is a topic, and I've got a service. So the client is going to set up a subscription to the topic, and so is the service. In a similar sort of way that we did with the queue just now. So they both set up a subscription to the topic, and the client's now sent a message to the topic. The problem we've got is that they both subscribe to the topic, so the client will get its own message back as well as the service getting the message back. And so this brings us on to the subject of filters. There's 3 types of filters. So we've got SQL filters, we've got correlation filters, and we've got Boolean filters. They're quite interesting filters, not least of which because of the names. So SQL filters aren't really SQL. They're SQL-like, but they're not what you think. But you can essentially filter. You can filter message properties in a SQL-like syntax. The correlation ID filter isn't only for correlation ID. You can use it for other things. Boolean filters are a facade over the SQL filter, so it's basically a way of having a SQL filter that just applies to a Boolean value. Okay, so we've got a demo on correlation IDs and filters, or with filters. So we'll just quickly get the code back up here. and we've got correlation IDs. Okay, so service bus correlation ID. There we go. Start up. Okay, so just going to check the subscriptions out for that. Yep, they are. Okay. And we'll run this. And then we'll run a second instance. There we go. Okay, so we've now got 2 instances. So what I'm going to do is I'm going to send the message from instance 1 and await a reply in the same way. And then I'm going to reply on instance 2. So it's a very similar idea. And exactly the same sort of behavior. And I won't do because we're running out of time, but if I did it with the incorrect one, it would have the same effect as before. And the way that we're avoiding the scenario I just showed you with topics is we're using filters. So essentially what I've done here, it's the same sort of idea with the send. So I'm just sending a message as before, but this time I'm reading the message, and what I'm doing here, I'm setting up subscription clients. That's what you saw before, but I'm getting some rules, and basically I'm looking for this rule only to me, and basically as I send the message, I can filter that the rule is set up so that it's it'll only come through if it's got this to property set as my unique client name. Any other messages will be ignored. Okay, so correlation IDs using topics. We're running quite low in time, so should just get time for sessions. So sessions are interesting, and I think I'm right in saying that Azure is the only, or Azure Service Bus is the only service that actually supports sessions. And these were designed essentially to do what we've just done with topics and queues using the correlation ID, but in a more request response way. These do guarantee first in, first out. However, when you set up a queue, you kind of have to decide whether you want it to be a session queue or you don't. You can't mix them. And also they're not available in the basic tier, which means they're slightly more expensive. And the way they work is this: if we've got these sessions here, so I've got 5 messages and they're across 2 different sessions. And what happens is it sorts them into virtual queues. So essentially you end up with kind of 2 virtual queues. Again, a quick Azure CLI snippet here. So to set up a session enabled queue, it's service bus create and then give it the namespace, and then just tell it needs to be session enabled. You can't mix sessions and non-sessions. Okay, so let's see if we can get a quick demo in with sessions. So queue session demo. I'm going to do this on queues. I've given this talk before, and one of the questions was does this apply to topics? And the answer turns out to be yes, it applies to topics as well. So pretty much anything you can do with a queue, you can also do with a topic subscription. Okay, so going to run this up. And going to send some messages. And we're going to have a look in Service Bus Explorer as to where the messages are. So if we have a look here, we've got 2 messages that have been added. I've got a message and I've got what I've called a noise message. And obviously these are on 2 different sessions. So what I'm going to now do is I'm going to receive the messages. So this would be option 2. And then if I go back to the Explorer and refresh it, you'll see that only 1 message has actually been deleted. And the other one, the noise message, has been left because I've only received on session 1. So what I'm going to do now is I'm going to launch a second instance. Just bear with me while I reorganize some stuff. Get my Visual Studio back. Okay, so with the second instance, so now I'm going to send a message and await a reply in a similar sort of way that we did before. So that's going to send the message. And now we're going to receive the message here. Okay. So we've got the lyrics of a song here, and we're going to find out what song those lyrics are from. If this was a face-to-face session, I'd be asking if anyone in the audience knew, but unfortunately it's not. And now what I'm going to do is I'm going to reply to that message, and any Rainbow fans will have recognised that. So let's have a look at what actually happened there in the code. We're in very short time, so I'm going to quickly run through this. So yeah, send the message, same idea, except we're now specifying a session ID. Just realised there's a load of questions that I've missed here. Presumably autocomplete is false, is faster than peak, followed by a read. Yes, I believe so, although I've never measured it. If I did a peak followed by a read, would it be guaranteed that the read would see the same message as I peaked? So what you would do is you would receive the message. I think we did that earlier. Basically, I can't remember where it is, but basically what you do is you receive the message, and then in the message itself you say, I'm going to complete this message, and that effectively is the same. So you lock the message, you read the message, you lock it, and then you complete it. What are the others? For real-time data feed into the data warehouse, would it be better to use a service bus or API? That's a big question. I would say perhaps. I mean, for something like a real-time data feed, you might want to look at one of the other Azure offerings that are sort of closer to sort of real-time data. But yeah, sorry if that's not a particularly good answer. Okay, so on with this code. So yeah, we specify the session ID there. Reading the message, all we're doing here is we're saying set up a session client, as we did before. And this time, instead of receiving the message, we do this accept session async. So we're essentially we're saying we're going to receive the message for this session only. So it gets the next message from that session off the queue, and then we'll receive it. And then here, so that is similar to what I was just responding to. I think it was Richard's comment before, which is now that I've got the message, I'm completing it and I'm doing that manually. So if you don't do receive and delete, where it automatically deletes it, you're kind of responsible for doing it yourself. There's also, I think, an abandon async, which will put it in the dead letter queue. And I've not covered dead letter queues here just because it's under an hour. And we're getting very, very close to that limit. Okay, and then I've sent that to the wrong screen. Bear with me. Okay, so other advanced features just quickly. So touched a little bit on dead letter queues. So dead letter queues effectively are a sort of storage for anything that the basically anything that goes wrong. So if you can't be delivered, it's rejected, it times out, it ends up in a dead letter queue. There's a feature called message deferral, which is effectively you're receiving a message, but you say, I don't want to receive it now, I want to receive it later on. Auto forwarding, you can for example, you can receive messages into a queue and then forward them onto a topic. And scheduled delivery. So there was a demo that I had for scheduled delivery. I'm not going to get time to do that, but essentially that allows you to send a message at a given time. What I will do, I haven't got time to show you the message delivery, but I will just quickly show you the code behind it. Essentially, if you want to schedule a message to send at a later date, then you would do this. So you would set up a queue client and then you would say schedule message and give it a date and time, and then it would execute at that time. That gives you back a sequence number and you can cancel that message. And so in summary, you can use a message broker to separate services and processes in your system. For long-running processes, you can use correlation ID, or you can use the request response. And I think sessions allow for a more fluid call pattern. Okay, so all of the code on this talk is at that location, my GitHub repo. I'm on Twitter if you've got any questions that we didn't have time for. And I think I'm going to be told that we haven't got any time for questions, but that's liberty. Have we got any time for questions, or are we out?
Go for it.
Okay. Is there any other questions that I haven't answered? I think I might have got through all of the ones that are published.
At the bottom.
Is message only ever a string? Can I use it a class age? Yes, you can. You can serialize. You can serialize anything that's serializable. So it can be anything you want. In fact, you can even send. And I've never tried this, but you can send binary things. You can send images and so on over a message bus. And with a queue, can you have multiple listeners? Yes, you can have multiple listeners to a queue. Is message guarantee is a message guaranteed exactly only once? It's, I think I'm right in saying this, although I'll go and double check this. Yes, it's guaranteed to be delivered only at most once, but not only once. And you just don't know exactly which receiver will get it. Yes, that's true. So if you've got 20 receivers and they're all kind of having a look at the same queue, then no, you don't know which receiver is going to get it or which one's going to process it. I think that's all of the questions. So thanks everyone for coming to the talk.